If you ask me what's tech world's most discussed topic today, my answer is microservices. Why? Many organizations have applications built with monolithic architectures that are becoming increasingly difficult to maintain, debug, and innovate. How can they make those applications more efficient and scalable? Microservices is the answer to these problems. So, let's deep dive into microservices and understand it into more detail. Microservices architecture is a collection of loosely coupled services communicating through a lightweight protocol. Each microservice is a self-contained component that can be developed, deployed, and maintained separately. These services have a separate code base that is managed by a small team of developers. So, if a team needs to update an existing service, it can be done without rebuilding and redeploying the entire application. Using well-defined APIs, these services can communicate with each other. The internal implementation of these services doesn't get exposed to each other. Let's look at some advantages of microservices. 1. Independent development and deployment. Each of the services in microservice is deployed independently. As we have discussed that a small team takes the responsibility for these services to build, test, and deploy them. This enables faster development. Also, it becomes easy to fix the bug and release the features. 2. Small code base. A code base or database is not shared. Dependency gets minimized, and it becomes easier to add new features. Also, it becomes easier to understand the code and add new features. 3. Mix of technologies. In a microservices architecture, you're free to choose any technology that suits best for your service. 4. Fault isolation. In a microservice architecture, you can easily handle critical points of failure. If a service goes down, the functioning of the whole application won't stop, as long as any upstream microservices are designed to handle the failure. 5. Scalability. You break down the application into smaller services, and that makes them easy to scale independently. You don't need to scale the entire application. 6. Data isolation. Schema update is easier to perform because only a single microservice gets affected. Disadvantages of microservices. Complexity. Services are simpler in microservices, but the whole system is more complicated. Testing. Writing tests will be more complex if services will be dependent on each other. To unit test, a dependent service mock must be used. Data integrity. Microservice support distributed database architecture. Each service in microservice is responsible for its own data persistence. Data integrity or data consistency can be a challenge in these situations. Network latency. Many small services in microservice require more inter-service communication. If services in microservice will have a long chain of dependencies, then additional latency can become a problem for you. You will have to design the APIs carefully. Best practices. 1. You can model the services around the business domain. 2. We have discussed that individual teams are assigned for specific services, so there is no need to share the code or data schemas. 3. For each service, data storage should be private. You need to use the best storage for each service and data type. For each service in microservice should communicate through well-designed APIs. Implementation details shouldn't be leaked. 5. Coupling should be avoided between the services. The coupling has various causes, including shared database schemas and rigid communication protocols. 6. You should keep domain knowledge out of the gateway. Routing of client requests should be handled without the knowledge of business rules or domain logic. This should be taken care of very carefully, or you will be facing the coupling problem between the services. 7. There should be loose coupling and high functional cohesion between the services. Functions that change together should be packaged and deployed together. If the functions reside in separate services, then this should end up being tightly coupled. Updating one service requires updating the other service. Use cases for microservices. Website migration. Complex websites hosted on monolithic platforms can be migrated to cloud-based and container-based microservices platforms. Media content, images and video assets can be stored in scalable object storage systems and served directly to web or mobile using microservices architecture. Transactions and invoices, payment processing and ordering can be separated into independent services, ensuring payments continue even if invoicing faces issues. Data processing, microservices platforms can extend cloud support for existing modular data processing services. That concludes our today's video on microservices. Thank you for watching. Comment below if you want me to cover any more topics like this. Please like, share, and subscribe to this channel for more videos. Happy learning!